In this video, we want to learn how we can solve quadratic equations using the completing the square method. As you know, we have different methods for solving quadratic equations, like factoring method or quadratic formula. But here we want to focus on the completing the square method. The first step in the completing the square method for solving quadratic equations is to get rid of this constant from the left side of the equation. So we have to move this constant to the other side. For example, here in this example, we have to subtract 8 from both sides of the equation, and then we have x to the 2 plus 6x equals negative 8. In another word, we move this constant to the other side. But because it goes from left to right, 8 becomes negative 8. As you know, when we move one term from one side of the equation to the other side, we have to change the sign of that term. So 8 goes to the other side and it becomes negative 8. Now, this is the most important step in solving quadratic equations with the completing the square method. Now, we have to add a number to the both sides of this equation. But what is that number? This is the most important step in solving equations, quadratic equations, with the completing the square method. The number that we have to add to the both sides of the equation is half of this number squared. So a square half of this number. Half of 6 is 3. So basically you have to divide the coefficient of x by 2 and then square that number. 6 divided by 2 is 3. 3 squared is 9. So in this example, we have to add 9 to the both sides of the equation. And don't forget, you have to add this number to the both sides because you want to have these two equal to each other. If you add 9 to the left but not to the right, then these are not equal anymore and we don't have any equation anymore. So this process is the most important step. Half of this number is squared. Half of 6 is 3. Square that, it is 9. Now, if you look at the right side of the equation, negative 8 plus 9 is 1. Now, this expression is a complete square, is a perfect square. X to the 2 plus 6x plus 9 is x plus 3 squared. If you wonder how we write this expression, the first term is always x. But how we write this 3? Half of this number again. So half of this number is very important. Half of this number squared goes here. Half of this goes here. Half of 6 is 3. Now, as you can see, we have a very simple equation here. Now for solving this equation, x plus 3 to the 2 equals 1, we take a square root from both sides. Then we have x plus 3 equals plus minus a square root of 1. But the square root of 1 is 1. Don't forget, when you take a square root, don't forget to put plus minus outside of the radical. Our equation has two solutions. If we move 3 to the other side, don't forget when you move a number to the other side, it becomes the opposite sign. We have plus 3 here, it goes to the other side, it becomes negative 3. Or in another way, you can say we subtract from both sides of this equation by 3. The result is the same. So finally, we have x equals negative 3 plus minus 1. If we simplify these two answers, negative 3 plus 1 is negative 2. This is one of the answers. Negative 3 minus 1 is negative 4. These are the two answers, the roots of this equation. So this equation has two solutions, and those solutions are negative 2 and negative 4. By doing more examples, you will see that this method seems at first really complicated, but gradually it becomes easy if you practice enough. Maybe you wonder why we have to learn this technique while we have easier methods like factoring or quadratic formula. This technique is important not only in solving quadratic equations. These are the things that the students maybe don't know. In the future, when you take more advanced course like calculus, you will see that in many parts of calculus, we need to be able to write a quadratic expression in the completing the square form. And at that point, the methods like factoring or quadratic formula doesn't work because you want to just write an expression in the completing the square form. Or also, when you want to graph a quadratic function, it's useful to know how to write the quadratic function in the vertex form, which is basically the completing the square form. So this method is not only important for solving equations. Now look at this example. X squared minus 8x plus 13 equals 0. Here, similar to the previous question, first we get rid of 13. So we move 13 to the other side and then we have negative 13. Then what we have to do? We have to add a number to the both sides of the equation. What would be that number that we have to add to the both sides? Half of this number squared. Half of negative 8 is negative 4. S squared negative 4. Negative 4 to the 2 is 16. So we add 16 to the both sides. Then we have this. Negative 13 plus 16 is 3. And the left side is x minus 4 to the 2. Again, this negative 4 is half of this number which goes here. Now, we are almost done. We take a square root from both sides. X minus 4 is plus minus radical 2. And finally, x is 4 plus radical 3. And the other x is 4 minus radical 3. So basically this equation has two solutions. 4 plus radical 3, 4 minus radical 3. As you can see, by doing more examples, we can get faster and faster and we can do this process easier. Now look at this example. X to the 2 minus 5x plus 4. Again, similar to the previous questions. First, we have to move the constant to the other side. X to the 2 minus 5x equals negative 4. 4 goes to the other side, it becomes negative. If it was negative, when it goes to the other side, it would be positive. Now what we have to do? X to the 2 minus 5x. Now we have to add a number to the left and to the right. Half of negative 5. Half of negative 5 is negative 2.5. But if you want to raise this to the 2, probably it's not going to be so much interesting. Instead of writing negative 5 over 2 by like negative 2.5, it's better to write it in the fraction form. Half of negative 5 is negative 5 over 2. So half of negative 5 is negative 5 over 2. But raise this to the 2. Then it would be 25 over 4. So we have to add 25 over 4 to the both sides. Like this. Now let's simplify the right side of the equation. What is negative 4 plus 25 over 4? If we do a common denominator, if we give a denominator 1 to negative 4, then we have 4, we multiply denominator by 4, and we multiply numerator by 4, it's negative 16. Plus 25 over 4. Negative 16 plus 25 is 9 over 4. So we have 9 over 4. So the right side of the equation is 9 over 4. What about the left side? As you know, now we can write the left side as a perfect square expression. X minus half of this number, 5 over 2 to the 2. From this point, we are almost done. We take a square root from both sides, plus minus radical 9 over 4. 9 is a perfect square. 4 is also perfect square. 9 is 3 to the 2, 4 is 2 to the 2. So radical 9 over 4 is basically 3 over 2. So let's write 3 over 2 here. And now from this, x equals 5 over 2 plus minus 3 over 2. The two answers are 5 over 2 plus 3 over 2 is 8 over 2. 8 over 2 is 4. 5 over 2 minus 3 over 2 is 2 over 2, which is 1. So the two answers of this equation, the two roots of this equation are 4 and 1. Look at this example. As you can see, the leading coefficient, this number here, is not 1. So far, all the examples that we have seen, the leading coefficient is 1. So let's see what changes during the process of solving the quadratic equation when the leading coefficient is other than 1. The first step is the same as before. We move the constant to the other side. So 3x to the 2 minus 12x equals negative 7. At this step, when the leading coefficient is 1, we add a square of half of this number to the both sides of the equation. But here, we have to make the leading coefficient 1, then we do that step. For that, first we have to factor 3 from these two terms. So, from these two terms, we factor 3. Then we have 3 bracket, x to the 2 minus 4x is equal to negative 7. Now we do that step. What was that step that we have to do in solving the quadratic equation with the completing the square method? We add a square of half of this number. Half of negative 4 is negative 2. A square of negative 2 is 4. So we add 4 in the bracket, x to the 2 minus 4x plus 4. Don't forget that you have to add a square of half of this number to the inside of the bracket, because we want to write this bracket as a perfect square. But attention, this 4 is inside of the bracket, so you have to multiply this 4 by 3. This is the number that actually you have added to the left side, because this 4 is going to be multiplied by 3. 3 times 4 is 12. So you have to add basically 12 to the other side, not 4. This is a common mistake. Negative 7 plus 12. Let's review this step, which is new. We add half, a square of half of this number to the inside of the bracket. Half of this number is negative 2. Negative 2 squared is 4. But because we added 4 to the inside of the bracket, it's going to be multiplied by 3. 3 times 4 is 12. This is the number that we have to add to the other side. Now, we can write the expression inside of the bracket in the form of x minus 2 to the 2. This is as before. And negative 7 plus 12 is 5. Please attention how we write the expression in the bracket. As before, half of this number, half of negative 4 is negative 2. X minus 2 to the 2. Now for finding x, first we divide both sides by 3 to get rid of the 3. Then we have x minus 2 to the 2 is 5 over 3. Take a square root from both sides. Then we have x minus 2 is plus minus radical 5 over 3. So x is 2. We move 2 to the other side. 2 plus minus radical 5 over 3. And this is the answer of the equation. These two roots are the solutions of the equation. If you want, you can rewrite this answer in this form as well. Please attention. What are the answers that we have? 2 plus minus radical 5 over 3 can be written as radical 5 over radical 3. If you like, this is optional. You can rationalize this expression. And to rationalize this, you can multiply the numerator and denominator by radical 3. Then you can write your answer in the form of 2 plus minus radical 5 times radical 3 is radical 15, and radical 3 in the times by radical 3 is 3. If you like, you can write the final answer in this form as well, but this is completely optional. Look at this example. Negative 4x to the 2 plus 4x plus 15 equals 0. Again, as you can see, the leading coefficient is not 1. But the other thing that we can notice is that the leading coefficient has a negative. And usually, we prefer not to work with negative numbers, especially when the leading coefficient is negative. So, it can be a good idea. This is completely up to you, but it's a good idea to get rid of the negative here. But how we can get rid of that negative in the leading coefficient? As you know, we can do anything with the equation as long as we do that operation to the both sides. So to get rid of this negative, simply we can multiply both sides of the equation by a negative. By doing that, this equation becomes 4x to the 2 minus 4x minus 15 equals 0. So we multiply every term in the left by a negative, and then the equation would be like this. And if we multiply the right side by a negative, negative of 0 is also 0. So as you can see now, the leading coefficient is positive. Now we have to factor 4 from left side, and we have to move 15 to the other side. I am going to do 2 steps at 1 step, because gradually we have to be able to solve quadratic equations with the completing square method faster. So we moved 15 to the other side, and we know that when the leading coefficient is not 1, we have to factor that leading coefficient. So we did that. From these two terms, we factored 4, and then we have this expression inside the bracket. Now we have to do adding a number. But what number we have to add inside the bracket? Let's write the x to the 2 and minus x. Half of this number and square that. Half of negative 1, the coefficient of negative x here is negative 1. Half of negative 1 is negative 1 half. So negative 1 half. Square that number. It would be 1/4. So we have to add 1/4 to the left. And of course, we have to add not 1/2 to the other side. Remember, when you add a number to the inside of the bracket, that number should be multiplied by this number. Then it should be added to the other side. 1/4 times 4 is 1. So we have to add 1 to the other side. Again, what is the reason that we add 1 to the right side but 1/4 to the left side? No, attention. This 1/4 is inside the bracket. When you multiply 4 inside the bracket, 4 times 1/4 is 1. And we added exactly the same value to the other side. Now, we can write the bracket as a perfect square. What is the perfect square? X minus 1/2 to the 2 equals 16. 15 plus 1 is 16. How we write this expression inside the bracket? Always we have x. Then half of this coefficient, half of negative 1 is negative 1. To solve this equation, first we divide both sides by 4. Then we have x minus 1/2 to the 2 equals 4. 16 divided by 4 is 4. Take a square root from both sides. Then we have x minus 1/2 equals plus minus radical 4, which is 2. So the two answers are x equals 1/2 plus 2, x equals 1/2 minus 2. 1/2 plus 2 is 5/2. 1/2 minus 2, if you do a common denominator, is negative 3/2. For example, 1/2 minus 2 is 1/2 minus 4/2. 1 minus 4 is negative 3. So we have negative 3 over 2. So the two roots, the two solutions of these equations here are 5 over 2 and negative 3 over 2. These are the roots of this equation. Look at this example. X to the 2 equals 3/4 x minus 1 over 8. First of all, we know that we have to have all the terms of the equation in the left side, and we have to have only the constant in the other side. But the other thing that we notice here is that we have fractions, and we don't like to work with fractions. We prefer to work with integer numbers like 2, 5, 4, negative 3. We don't like to work with 3 over 4, negative 1 over 8. It would be so hard to work with fractions, especially when we want to do the completing the square. So here, first let's get rid of fractions. What are the fractions? What are the denominators of the fractions? 4 and 8. How we can get rid of 4 and 8 from this equation? Simply, when in an equation we have fractions, coefficients like 4, 2, 5 in the denominator, to get rid of those numbers, multiply both sides by an appropriate number. The number that works for this case is 8, because if we multiply both sides of this equation by 8, all the denominators goes away. Let me show you. So first we multiply both sides of the equation by 8. Then we have in the left side 8x to the 2. But we have to multiply the right side of the equation, this also by 8. Let me show you what happens when we multiply the right side by 8. We have 8 times 3 over 4x minus 1 over 8. 8 times 3 over 4x is 6, because 8 times 3 is 24. 24 divided by 4 is 6. The better way to multiply 8 by 3 over 4x is to simplify 8 with 4 first. We can simplify numerator with denominator in multiplication of fractions. 8 with 4 simplifies, and we have 2. 2 times 3 is 6. So we have 6x. When we multiply 8 by 3 over 4x, the answer is 6x. So let me write this here, 6x. What is 8 times negative 1 over 8? 8 with 8 cancels, and we have a negative 1, so minus 1. So when we multiply the right side of the equation by 8, we get 6x minus 1. So let me erase all of this from here. By multiplying both sides by 8, we have in the right side 6x minus 1. Now we have a normal equation without any fraction. But remember, for doing the completing the square, we have to have all the variables, all the terms with x in the left side, and only the constant, the number, in the other side. So we keep the negative 1 in the right side, and we move 6x to the left. Then we have 8x to the 2 minus 6x equals negative 1. Because the leading coefficient, as you can see, is not 1, it is 8, we factor 8. Then we have x2 minus 6 over 8, which is 3 over 4. 6 over 8 is 3 over 4. X equals negative 1. Now is the most important step. What was that step? Adding something to the both side. X to the 2 minus 3 over 4x. What number we have to add? Remember, a square of half of this number. What is half of negative 3 over 4? Half of negative 3 over 4 is negative 3 over 8. The reason is that if you want to find the half of this number, negative 3 over 4, basically it means that you want to divide negative 3 over 4 by 2. This is like negative 3 over 4 times by 1/2. Multiply top by top, bottom by bottom, it's negative 3 over 8. So if you want to find half of a fraction, half of a fraction like this, half of a fraction is double the denominator, and that's the answer. For example, what is half of 5 over 7? Half of 5 over 7 is 5 over 14. it should not take so much time from you to find the half of a number. So half of negative 3 over 4 is negative 3 over 8. But we have to square that number. So we have to square negative 3 over 8. What is the square of that? 9 over 64. So we add 9 over 64 to the inside of the bracket. But is this the number that we have to add to the other side? 9 over 64? No, of course not, because we have 8 outside. Multiply 8 by this number, then add that to the right side. So to the right side, we have to add 8 times 9 over 64. The bad way to calculate this is to multiply 8 by 9, then divide by 64. The better way is to simplify first 8 by 64. 8 with 64 cancels, because 64 is 8 times 8. This cancels with this is completely gone, and what remains from this? 8. So it would be 9 over 8. This is the thing that we add to the right side. So 8 times 9 over 64 is 9 over 8. Negative 1 plus 9 over 8, negative 1 plus 9 over 8 is 1 over 8. Because this is negative 8 over 8, negative 8 plus 9 is 1. So we have 8 times x minus 3 over 8 to the 2 equals 1 over 8. Where this comes from? Half of this number. Divide both sides by 8 first. By dividing by 8, we have 1 over 64. Please pay attention. When we divide 1 over 8 by 8, because we divided both sides by 8, that's the reason this is gone. When we divide both sides by 8, 1 over 8, which is in the right side, by divided by 8, is 1 over 8 times by 1 over 8. 1 over 8 times 1 over 8 is 1 over 64. Now we are ready to finish this question. Take a square root from both sides. By taking a square root from both sides of this equation, we have x minus 3 over 8 is equal to, this is 8. X minus 3 over 8 is equal plus minus 1 over 8. A square root of 1 over 64 is 1 over 8. A square root of 1, a square root of 64, 8. And don't forget plus minus. So what is x finally? We have two values for x. 3 over 8 plus 1 over 8. 3 over 8 minus 1 over 8. 3 over 8 plus 1 over 8 is 4 over 8, which is 1/2. 3 over 8 minus 1 over 8 is 2 over 8, which is 1/4. These are the roots of this equation. I hope by watching this video, now you have learned how to solve quadratic equations with completing the square technique. If this video was helpful for you, please subscribe to my channel and see you in the next videos.